Hello, Math 109 students. This will be the last video of the quarter. And I always tell students in class, this may be the most important uh, day of math class that you ever have because it truly could change your life and the life of your family after you. We're going to talk about money. We're going to talk about the power of compounding interest as it pertains to an exponential function. So here's the formula. Formula for compounding interest would be A equals P times 1 plus R over N raised to the NT power. Let me tell you what these variables mean. The A is the final amount. P is the principal. So principal means the initial amount. All right, the next thing, that's just the number 1. The R is the interest rate. As a decimal. The N in both of these places here, that is the number of compounding periods I'm going to make this simple for me. Try to make this simple for you by just saying this is the number of compounding periods per year. It doesn't have to be per year. It could be per any unit of time, but this needs to be whatever this unit of time is. It needs to be the unit of time for the interest rate as well. So we're just going to say this is the annual interest rate. I don't know if annual has 1 or 2 N's. Annual. Anyway, so the interest rate is per year as well as this N is the number of compounding periods per year, just to make it simple for you, because that's how it's usually the information is usually given. So if it's like, if it says compounded annually, then N would just be 1 because it just means it's compounded once per year. If it says compounded semi-annually, that means the N is 2 because it's compounded twice per year. If it says compounded quarterly, then quarterly means 4 times a year. So N would be 4. If it said weekly, that would be 52. If it said daily, that would be 365. If it said monthly, what would it be? N would be 12 in that case. All right, and T is the time. And we're just going to say, again, to keep it simple, in years. But this unit of time needs to also match the unit of time for R and for N. And it doesn't have to be years, but we're going to keep it simple and make it just be years. And that is the formula for compounding interest. Or we could say for anything that is gaining in value, or we could even make this a minus sign if it was losing value. Like something that might be gaining value might be like an antique, something that's rare. Something that would lose value would be something like a new car that you just drive off the lot. It's going to lose value immediately. So then we would have a minus sign there to see how much value it would lose. Let's see. Another formula that you need to know is what if it's compounded continuously? Continuously means it's compounded every infinitesimally small unit of time that passes by, it's compounded again. So that's what continuously means. And to handle that, we use the natural number E. And so it just the P, the R, the T mean the same thing that they did here. And the E is just that natural number that we talked about earlier. It's like around 2.78. So you could remember this as PERT. P-E to the RT power. So here's where it gets really cool for you. All right, imagine this scenario. Imagine you finally finish your education and you get yourself a decent job. Not some wonderful, extravagantly paid job. Not some terrible minimum wage job. But you get yourself a decent job after you've gone through your college education that you're trying to get right now. And let's just say you make about $40,000 a year. That's pretty decent money. It's not great. It's not terrible. You can live decently on $40,000 a year for sure. And let's say that you say, hey, Mom and Dad, let me live with you just 3 more years while I save my money. I know for some of you that might seem like a torture, or others of you it might seem like, well, yeah, that's fine. But just imagine this. This is just to teach you something about money here, okay? So in this scenario, you live with your parents, and so that you can save on your bills, so that you're then able to save. Hypothetically, let's say you're able to save half your salary for 3 years. So you're able to put away $20,000 a year for 3 years, so that you're able to put away $60,000. And you now keep in mind, you still have $20,000 each of those years to live on, and that's without having the expenses of having a place of your own and such. So you should be able to live pretty comfortably like that for those 3 years as well. But you put away $60,000, and let's say you put it into the stock market, an account in the stock market, mutual fund, or index fund, or something like that. And let's say you gain 10% per year, compounded quarterly, quarterly. And let's say you do this when you're 22, and you keep it in there for 30 years. How much would you have at the end of those 30 years? At age 52, how much money would you have? All right, let's type that into our formula. What are we looking for? We're looking for the final amount. $60,000 is the principal. That's the initial amount that you put in, that you invest. 1 plus, and R is 10%, so we're putting it as a decimal. 10% as a decimal is 0.1. Remember, to change the decimal to a percent to a decimal, you move the decimal point 2 places to the left. Percent means per 100, so you divide it by 100, so it means that's 10% is 0.1. N, since it says compounded quarterly, N is 4. And T is the time in years, so that's 30. Now type that in your calculator and tell me how much money you've got. 60,000. 1 plus 0.1 over 4 raised to the 4 times 30 power. Do you see that number? $1,161,488.99. $1,161,488.99. Make sure I got that right. You are now a millionaire because you saved money early in your life. Because you were wise with your money early in your life, 30 years down the road, your life has changed. Not only is your life changed, the life of your children and all your children's children after you will also be changed. The significance of this number is, instead of buying that fancy car that you wanted to buy when you got that great job, that decent job, you didn't buy that fancy car. You saved your money, And now, 30 years later, you're able to buy a couple of Corvettes in two colors that you like. And you're able to get you a 99-cent bacon cheeseburger so that when you got your top down, you got your 99-cent bacon cheeseburger in your hand, rolling down the road in your Corvette. And you still got $1 million in the bank. I wish we were in class so I could see your faces and you could see my face. There is no reason that anyone in America can't be a millionaire if you just work hard and are wise with your money. No reason. You might say, well, Mr. Rowe, are you a millionaire? I ain't 50 yet, but I've been saving my money, y'all. Don't you come to me. Don't you come to me. I ain't giving you nothing, but I am giving you the most valuable thing. I'm telling you how to do it yourself. How you can do it. And it's totally possible. And let's say you can't do the $60,000 earlier in your life. I didn't do that. But what I'm doing is I'm sending a significant chunk of my money to the bank, to the stock market, in the mutual fund or index fund. Every paycheck I get, that money goes. And it has been doing that since I began working in my early 20s. And it will continue to do that. I'll tell you more about this in just a second. Some objections to this may be, well, how do you know you're going to get 10% a year in the stock market? Your money you might lose your money in the stock market. Yeah, so you should live your life based on probability. Make your decisions based on you can never be certain about what's going to happen. But you know that if you buckle your seatbelt, you'll be more likely to live in a car crash than if you don't. So you buckle your seatbelt. Doesn't mean you definitely will live, but you're more likely to live. Same thing with the stock market. The stock market has historically gained an average of 10% per year, around about. And that's through the highs and the lows, the crashes, the recessions, and all the recoveries. So if you're investing for 30 years for the long haul, you're not worried about a recession. You're not worried about too much worried about a crash. All you're worried about is the fact that you invested here, and this is time, and the stock market does its thing. And it's going to do all kind of crazy stuff, right? But you don't care about all that crazy stuff. All you care about is the fact that this is where you started and this is where you ended up. And after all that's said and done, you ended up here probably by averaging about a 10% interest rate of return per year. Again, I would recommend doing that, getting started on that as early as possible in life. Be an investor, have an investor mindset. That means you're not wasting your money. You're not throwing your money away on things that will not pay off in the long run. You're putting your money and your time and your everything into things that have a long-term benefit. That may be a sacrifice for now, but that pay off in the end. That's what it is to have an investment mindset. And that's different from most of America and most of the world. I mean, most people are just trying to make it day to day. They just want to make the day the best they can get it, and they're not thinking about tomorrow, or especially not 30 years from now. But if you want to make an impact, a lasting impact on the life of your family for the rest of, for generations to come, that's how you do it. And there's no reason that anybody in America can't do that. Especially since we have the ability to get a free public education. And then college is pretty darn cheap too. I mean, you can get a decent job if you will just apply yourself. So what other, so mutual funds or index funds is usually what you want to do instead of trying to pick a particular stock. Like I'm going to put all my money into Walmart or something, and then something happens and Walmart goes south. You don't want to. You want a mutual fund is in like thousands of stocks, thousands of companies. An index fund may be even better because it tries to follow the entire stock market. You may want to get a financial advisor. To help you do this. You could do it yourself on a website, on various websites. One is called TD Ameritrade. You can get into investing yourself that way, but your best bet might be the financial advisor route because they do this for a living. I have a financial advisor. My financial advisor makes like 1% off of my stuff, and that's totally fine with me. He can have 1% of my gain as long as he's trying to do what's best for me. And he's going to try to do what's best for me because if I make more money, he makes more money, and that's a good thing for both of us. If we were in class, I'd say, if you want the name of my financial advisor, talk to me after class. But since we're not in class, we can't do that. But maybe if we ever do get back to NC classes, if you're interested in this, come find me, and I can give you his name and number and contact info. If you know of another way to invest, if you want to invest in other kinds of things, if you want to like invest in your own business, like a dry cleaning business or a restaurant business, I mean, some of those things are very risky. Or a real estate business or anything like that, property management, sure, go right ahead. My life is devoted to other things. And so doing this doesn't take up much of my time at all. It just kind of automatically happens. And I'm going to get the benefit from it by this guy doing his job so that I can go about my life doing my job. And we both benefit. The government is going to come in and take a third of your money away, at least a third, unless you put it into a tax-sheltered annuity, TSA. Some things to look into there would be like a 401k or a 403b, same thing really, or what's called an IRA or a Roth IRA. Your financial advisor can tell you about that. Schwab's also another good one. Schwab, kind of like TD Ameritrade, and there's other good ones too. But these people you can call those people and they'll help you with customer service as well, and they're pretty good about it. If you put them into these tax sheltered annuities, then the government won't take your earnings, your gain from that. The only catch to that is I think you have to be like 55 and a half or 59 and a half, somewhere in there, before you can take it out, or you get a penalty. You get the taxes taken out. So, but you don't want to take it out until then anyway, because it's still growing. Let me show you mathematically what's happening here. This is the power of the exponential function. Here you are at age 20, and your money. This is the value of your money over time. Okay. Here you are at age 20. Here you are at age 30. It hadn't grown very much. Here you are at age 40. It's grown a pretty decent chunk by age 40. That's 20 years. But here you are at age 50, and you're way up there on the curve. And if you keep in there till you're 60, 70, 80, my goodness. And you're not going to spend all of it, right? So you're going to keep a lot of it in there. But that's the power of an exponential function, exponential growth. Now, it also works the other way. Imagine that this is, instead of value, imagine this is debt. Because this formula also works for debt, and the interest rate being the debt, the rate of interest on a loan. Like credit card debt's the worst, right? Because it's got such a high rate of interest if you leave debt unpaid on there. I mean, you're talking 20% interest. So it's going to be even worse than the stock market is good. But, bank loans, and, you got to get a loan a lot of us have to get loans to buy a house or to buy a car. And if, you want to look for the lowest interest rate possible and make your payments on time, and you won't get penalties and stuff like that, and that's fine. But if you just live by debt, especially credit card debt, that's a bad way to go, because the power of this curve is actually working against you. That curve is the mountain of debt that you're accumulating over time, instead of the mountain of wealth that you're accumulating over time. So live your life as debt-free as possible, and is invested into things that will probably, the probability is on your side that it will make you money in the long term. And that's going to be the best way to live your life financially. I hope that this may make a difference for you and your outlook on money and life, and maybe it can make a difference not only in you, but in your family as well for the long run. I'm going to go back now to Math Excel and look at some problems to make sure we can do those problems. So we're looking at number 36 here. Jerome is contemplating the purchase of 100 shares of a stock, selling for $15 per share. So that means the total there, 100 shares, $15 per share. The total there would then be $1,500. The stock pays no dividends. That means that it's not going to pay you extra. Like if you invested in a real estate property and somebody was renting it, then not only is the real estate growing in value, but you're also getting money from the renter. But that's not the case here. No dividends. The history of the stock indicates that it should grow at an annual rate of 18% per year. So there's R. So 1,500 is P. 18% is R. Use annual compounding. Annual compounding means once per year, so N equals 1. To determine how much the 100 shares of stock are worth in 7 years, so there's time. So A equals P, 1 plus R over N to the NT. Just plug in the values. We're looking for the final amount. Principal's 1,500. 1 plus 18% is 0.18 as a decimal. 1 goes in for N because it's just annually compounded. And so 1 goes in for N here too. And the time is 7 years. So just type that in your calculator to get your answer. And let's go on to the next problem. All right, if the average cost of college increased by 9.5% per year, what will be the average cost of college 14 years from now? So current cost, so there's the principal. That's the initial cost of college. There's R. R is 9.5% each year. And it just says each year. So that you're assuming that it's compounding once per year. So N equals 1. 14 years, there's time. So let's see if we can do it. A equals 30, 415 times 1 plus 0.095 over 1 raised to the 1 times 14 power. And that will tell you how much college will cost 14 years from now based on that information. So just type that in your calculator to get that answer. Part B, if a savings plan offers a rate of 5.7% compounded continuously, how much should be put in the plan to pay for 1 year of college 14 years from now? All right, so we actually have to find this answer to part A to be able to do part B. So let me type this in the calculator. I don't have to put that over 1 because over 1 doesn't do anything, right? And it's to the 1 times 14 power, so I'm just going to put 14. And that gives me 108,364. 108,364. That means 14 years from now, if college continues to grow, if the rate stays the same for the growth of how much college is increasing per year, the cost, then in 14 years, college will cost about $108,364. That's a lot. Let's see here. What do I want to know now? I want to know, all right, the savings plan offers a rate of 5.7. That's R, compounded continuously, so we're using PERT. So A equals P, E to the RT. All right, the final amount we want is this. So that's going in for the final amount. We're trying to get that much money. We're trying to say, what do we need to invest now to have that much money when we need it? How much should be put in the plan now to pay for 1 year of college 14 years from now? Okay, so that's per year. All right, so P, we're looking for P. P is the principal. That's the investment that we need to make right now in order to have that much money 14 years from now. So E to the 5.7%, so 0.057, and T is 14 years. So we're looking for P. So what I'm going to do now is I'm going to go ahead and type that in my calculator, because that can just be a single number if I type it in my calculator and get the number there. E to the 0.057 times 14. So second, E to the 0.0, I think I missed the decimal, 0.057 times 14. 2.221. So 108, oops. So 108,364 equals P times, what was it again? 2.221 or something like that. 2.221. 2.221. So now I just divide both sides by 2.221, and I will have P. So I type this in my calculator, 108,364. 108,364. Well, here's what I could do. Even easier. I can just go up there and grab that number and hit enter, and then hit divide by, and then go up there and grab that number and hit enter. $48,788.62. P equals 48,000. I'm not going to remember that number. 788 and 62 cents, because it wants us to round to the nearest cent. So that'll be what I type in part B. Part A, I would type in, if it wants the nearest cent in part A, I should type in not 108,364, but 108,364 and 12 cents from that number. So 0.12. All right, that is it. That finishes up Chapter 6 and Chapter 6 homework, which is our last new material for the year. So good luck to you on Chapter 6 assignment, and good luck to you on the test we have coming up. Hope you can use the practice test to get ready for it and make a good grade on that. And I'll see you again another time.